2, 3, 4.
Well, all right, you made it to the end of Unit 8, and we're ready for the test review to get ready to take the test. Well done, well done. Okay, we're going to look through some sample problems that are going to be somewhat similar to the problems that you'll see on the test, so this will be a good review, and I would suggest that you watch all of this video before taking the test. It says in problem 1, what is the domain and range of, in this case, this set of ordered pairs, this relation here. We don't know if it's a function yet. That's also something that's asked, but right now we do know it's a relation because remember that by definition, a relation is any set of ordered pairs. The domain, remember, are all of the x values. So I'm going to write the domain, and I'm going to put the little brace there. I have 0, 1, 8, and 5. I like to put them in order, so I'm going to go 0, 1, 5, 8. The range is made up of all the y values in the ordered pairs. That's all these guys. And I have 3, 4, 2, and 4. 3, 4, 2, and 4. So I'll put those in order. 2, 3, 4. I'm not going to write 4 twice. It's unnecessary. Now the question remains whether or not this is a function. And the answer is yes, it is. It is a function because every element in the domain is used only one time. Remember, it's not a function if you have the same x with different y values. That's not the case. I do have two different x's with the same y value. That's okay. That's still okay for it to be a function, not the other way around. So, is it a function? Yes, it is. Second question here. Is the ordered pair 1, 4 a solution to that? Remember, linear equations in two variables have infinitely many solutions. So I'm going to substitute it in, and if it makes it true, then it's a solution. If it makes it false, it's not. So this again in for the x, this in for the y, here and here in my equation. So 3 times 1 plus 2 times 4, 4 in for y, does that equal 11? This is 3 plus 8. Yes, it does. 11 equals 11. Yes, it's a solution. So that one works out just fine. Remember, if it makes it false, it's not a solution. Third problem, what is the x-intercept? That, of course, is where the line crosses the x-axis of the graph of 2x minus 5y equals 0. Now, if it was in slope-intercept form, we would be able to find the y-intercept because that's the plus b part on the end. But this is asking for the x-intercept, where it crosses the x-axis. Well, on the y-axis, the y-intercept always has an x value of 0. For the x-intercept, it has a y value of 0. Because any point on the x-axis has a y value of 0. You move right or left, but you don't go upward or downward to stay on the axis. So I'm going to plug 0 in for y right here and see if I can find x. 2x minus 5 times 0 equals 10. Of course, 5 times 0 is just 0. I have 2x equals 10. Divide by 2. I have x is 5. So 5, 0 would be the x-intercept, or just the 5, as the book likes to write just single numbers instead of ordered pairs. The fourth problem, what is the slope of the line that passes through the points 2, 3, and 1, negative 4? And then it asks some more, but let's find the slope first. So the first thing I'm going to do is use the slope formula. I didn't give myself too much room here, so I have to be careful to squeeze it in. I'm going to call this my x1. My y1, this my x2, my y2. Substitute them in. I get negative 4 minus 3 all over, looks like 1 minus 2. Negative 4 minus 3, it's like adding the opposite. This is like adding the opposite. I have negative 7 over negative 1, or positive 7. That's the slope of a line that's described that goes through those 2 points. Then it says, what's the slope of a line parallel to the line described? Well, it'd be the same. It'd also be 7. Parallel lines have the same slope. What about perpendicular? What is the slope of a line perpendicular to the line described? Well, that is the opposite reciprocal. The reciprocal of 7, which is like 7 over 1, is 1 over 7, so it's the opposite reciprocal. It'd be negative 1, 7. So this is the slope of the original line that goes through these 2 points. This is the slope of a line here. I'm going to get rid of that. That's parallel to this one, and this is the slope of a line perpendicular to the original. Now, this fifth example here says, what is the constant of variation in the in the direct variation shown. A direct variation would look like a line in the first quadrant here that goes through 0, 0. And I don't have my axes marked, shame on me, but there they go. And I have 2 points, so that's really going to be enough because the constant of variation is the slope of the line. So since I have 2 points, I can use the slope formula, or in this case, I'm going to go rise over run. That looks like I'm going up 2 to the right 1, up 2 to the right 1. My constant of variation, a lot of times they'll use a K, is 2. Okay, here we go. Problem number 6. Write the equation of a line that has slope 3 and a y-intercept of -5. Now, I like to write my y-intercepts as ordered pairs 0, -5, but I'm just writing that down because that's how most likely you're getting used to it from the book. So what I'm going to do here is go right to slope-intercept form, because they have given me the slope and they have given me the y value of the y-intercept. So that would be y equals 3x plus -5, which is the same as -5. So that was very simple. You just directly substitute in for the m and the b there. Now, problem number 7. What is the range of this linear equation, y equals 2x plus 1, when the domain is 1, 3, and 5? I mean, these are my x values. I need to find the y values. So if I plug 1 in for x, I get y equals 2 times 1 plus 1, which is 3. If I plug 3 in for x, I get y equals 2 times 3 plus 1. 6 and 1 is 7. If I plug 5 in, I get y equals 2 times 5 plus 1. That's 10 plus 1 is 11. So my range would be, I like braces around it, 3, 7, and 11. Alright, the next problem up says, given that f of x, now notice the function notation, that's not f times x, that's f of x, this is the same as your y, is equal to -3x plus 5. Then it says, what is f of 5? That means you're substituting 5 in for the x in the equation. -3 times 5 plus 5. This is -15 right here, plus 5, that's a -10, and that is f of 5. Problem number 9. Suppose f is a linear function. That means if you graph it, you get a line. And notice here, f of 1 equals 5, so that when x is 1, y is 5. And f of 3 is 11, so that means when x is 3, y is 11. What is the slope of the graph of f? Now, I don't want to graph this. I'm going to use the slope formula, which I did just a little bit ago. Remember, the slope formula was the difference in the y values over the difference in the x values. It's the rise over the run. And in this case, my ordered pairs are 1, 5, and 3, 11. Remember, these are the x's, and these are the y's that correspond. So I'll call this x1, y1, and I'll call this x2, y2, and I'll substitute right in. I get 11 minus 5, y sub 2 minus y sub 1, all over x sub 2 minus x sub 1, 3 minus 1. So this is 6 over 2. My slope is 3. Problem 10 says, is the ordered pair 1, -2 a solution of the, notice the linear inequality there, 2x minus 3y less than 7. So here again, we're going to substitute in x and y. We're going to plug those in for x and y here. I get 2 times 1 minus 3 times -2 less than 7. So this is 2. Now you have minus 3 times -2. It's like a -3 times a -2 is a positive or plus 6. So that gives me 8 is less than 7, which of course is false. So the answer to this problem would be no. If I had a true statement, then my answer would have been yes. All right, now problem number 11. How many solutions are there of the related linear system? I didn't state that very well, did I? How many solutions are there of the, maybe we should write that in, there we go. Are there of the related linear system? Now remember, linear system means 2 or more equations, and I have 2 graphs, and my solutions come from where the graphs intersect. So it doesn't want to know what the solution is, it just wants to know how many, and there's exactly 1. Remember, if the systems, there's only 3 possibilities. There's lines that cross like that and have one point that is in common to both lines, or you could have the same line twice and every point is, then it would be infinitely many, or they could be parallel lines and not have any solutions in common, so there might be 0. So it's either 0, 1, or infinitely many. Problem 12 in the upper right, it says, is the ordered pair 4, 3 a solution to the linear system? Well, for this to be a solution, it has to make both of them true. Well, I can almost see the top one that it's going to work. If I plug this in for x and this in for y, I get 4 plus 3 equals 7. I get 7 equals 7. That looks good. This one, it'd be 2 times 4 minus 3 times 3. Does that equal negative 1? This would be 8 minus 9, and look at that. Yes, it does. 8 minus 9 is negative 1. Negative 1 equals negative 1. So yes, that is indeed a solution. Problem 13, right underneath it, it says, which functions are linear? Linear, notice all my choices here have x's and y's, but linear means degree 1. Like a line is one-dimensional. So notice that this is x, like x to the first, and this is y, like y to the first. That's linear. So even though there's fractions, the x's and the y's are not in the denominator, that's okay. This one would be linear. Yes, it would be. This one here, same thing, no, without the fractions. X and y both, and to the first power for both, so yes it is. But this one, that's the exception. Notice the x is being squared. That means it's not linear. It's got a whole different name. It's called quadratic. You don't need to know that for the test, but you do need to know that no, that is not linear because of the x squared. Problem 14 says, what is the slope of a line that is perpendicular to the line with the equation y equals negative 3/4 x minus 7? Fortunately, that's in slope-intercept form. That's my slope. My slope is negative 3/4. But the slope of the line that's perpendicular to this line would be the opposite reciprocal. Flip it and change the sign, so it would be a positive 4/3. See how I flip it and change the sign for the opposite reciprocal. The last problem here that I have says, write the equation of the line that is parallel to the line given here, y equals 2x plus 7, and passes through the point 0, 1. Now very nicely, 0, 1, that's my y-intercept, and you can tell because the x values is 0. If it's parallel to this line, it has the same slope, and the slope of this line is 2/3. You can see because it's in slope-intercept form. So the slope I need is 2/3, and the b value that I need is 1 from here. So y equals mx plus b, y equals 2/3 x plus 1. And that would be the equation desired. Okay, so make sure that you take the time to look through these problems and to practice them, because I'm telling you right now, if you are a student that takes this test and does not use the review video, well, you're making this test much more difficult for yourself than you need to. So remember, practice, practice, practice.